Good morning, students of Prep 2 St. Joseph School. Now we're going to talk about Unit 1, Lesson 2, which is called the wave motion. First of all, to understand the meaning of wave, we have to imagine the shape of the water waves. Water waves is like the propagation of concentric circles on the surface of water. Concentric circles mean that too many circles having the same center. For the water wave, it's the disturbance that propagates and transfers the energy in the direction of propagation, which means that the energy transfers from one particle to another without moving the particle itself. Examples for the wave motion. When the tuning fork vibrates, the produced energy is transferred in the form of a sound waves. By the same way, the sound energy, transfers from one place to another without moving the particles of air itself. The concept of wave motion. It's the movement resulting from the vibration of the medium particles at a certain moment in a specific direction. So the particles vibrate in a certain direction to transfer the energy from one place to another without moving the particles itself. And the line of wave propagation is the direction of progression of wave. Types of waves. First of all, according to the ability to propagate and transfer the energy. We can classify the waves into two types. The first, mechanical waves. They need a medium to travel through. It depends on the particle's vibration, and their speed is relatively low, like the sound and water waves. You cannot talk to your friend in the space because there is no medium. So the sound is a kind of mechanical waves that need a medium to travel through, and medium in science means solid or liquid or gas. The second type is called electromagnetic waves. They do not need a medium to travel through, which means they can travel through space or they can travel through medium. Their speed is very high. It's 3 times 10 to the power 8 meter per second, which means 300 million meters per second. Like the light waves, X-rays, gamma rays, and radio waves. We can also classify the waves according to the direction of the vibration of medium particles. We can classify them into two types. The first one is called transverse waves. Transverse waves, they are the waves in which the particles of the medium vibrate perpendicular to the wave propagation. If the wave is moving forward, the particles will vibrate up and down. So, they are perpendicular to each other. And this wave, as we can see in this picture, it consists of crests and troughs. What's the crest? It's the highest point of the particles of the medium. Trough is the lowest point of the particles of the medium. Second type is called longitudinal waves. They are waves in which the particles of the medium vibrate in the same direction of the propagation of the wave. And as we can see in the picture, some particles are close to each other. They have high pressure and high density, and this is called compression. Some other particles are away from each other. They have low pressure and low density, and this part is called rarefaction. So, we can say that the longitudinal waves consist of compressions and rarefactions. Concepts related to the wave motion. First, the amplitude. It's the maximum displacement of particles away from their points of rest. And as we can see in the picture, the green line represents the amplitude, starting from the dotted line, the green line, the horizontal green line, and towards the maximum point. And this is called amplitude. So what's the amplitude is? It's the maximum displacement of particles away from their points of rest. Wavelength. The wavelength is the distance between two successive crests or troughs. If we move from the first crest to the second crest, this is called a wavelength. This is regarding the transverse waves. But the wavelength for longitudinal waves is the distance between two successive compressions or two successive rarefactions. So we can compare between transverse waves and longitudinal waves as the following. 1. Transverse waves, they consist of crests and troughs. Longitudinal waves, they consist of compressions and rarefactions. The movement of particles. Transverse waves, the particles of the medium vibrate perpendicular to the direction of the wave propagation, while in the longitudinal wave, the particles of the medium vibrate in the same direction of wave propagation. Wavelength. It's the distance between two successive crests or troughs, and this is for the transverse waves. The wavelength of longitudinal waves is the distance between two successive compressions or rarefactions. Finally, the examples. Transverse waves, like water waves, like light waves, but the longitudinal waves, like sound waves. Some concepts related to the wave motion. First of all, the periodic time. Periodic time, it's the time of one complete wave, the time taken to make one complete wave. And we can calculate it from the rule T equals total time over the number of oscillations. Then the frequency. Frequency can be defined as it's the number of complete waves made by the particles in 1 second. And we can calculate the frequency using the rule F equals number of complete waves per total time. Also, the frequency has some measuring units like hertz or wave per second or second to the power -1. Finally, the wave velocity. This rule, the law of wave propagation, can be used to calculate the velocity of any kind of waves, whatever its type is, if it's mechanical or electromagnetic or longitudinal or transverse. Any kind of waves, we can use this rule to calculate the velocity of this wave. Wave velocity, it's the distance covered by the wave in 1 second. And we can calculate the velocity by using the following rule, that the velocity equals wavelength times frequency, or wavelengths divided by periodic time. And we can conclude some relations using the following graphs. We can see that the relation between velocity and frequency is a direct relation, which means by increasing the velocity, the frequency increases and vice versa. Also, we have a direct relation between velocity and wavelengths. By increasing the wavelengths, the velocity increases. Finally, there is an inverse relation between frequency and wavelength. Real-life application. We can use the concepts of waves in making something called the physiotherapy tubes or jacuzzi. The jacuzzi is a tube where water moves in the form of a circular waves. Also, this jacuzzi can be filled with hot water or cold water according to the needs. If we use hot water, it's used to treat sprains and cramps, especially for the athletes after a big match or something. If we use cold water, we use it to deal with the nervous tension. And this is everything about this lesson.